So what is OSI model, right? Because we have some terms that are related to the OSI, right? So before we actually dive deep and understand what OSI model is, we need to understand what are protocols and standards, right? Because you realize that protocols are actually defined ways of how communication happen within a particular network. So in our case here, protocol will determine the syntax, right? This is a format of how the message is going to be passed from one communicating device to the other, right? You realize that before a particular message is transmitted, it has to be placed into some kind of syntax that both the sending and receiving device should be able to understand. And of course, you have semantics. We'll realize that in each and every message that is being passed across, there are kind of additional information that is being appended, right? That actually is meant to guide a particular sending or receiving device on what that particular message actually means. And of course, the timing, right? The communicating and the receiving device should actually understand at what point do this receiving device actually send an acknowledgement that it has received, right? This particular message. So we need to understand the timing of how a message is made. Talking about the standards, right? We have different organizations that actually provide the standards that this particular devices needs to adhere to, or rather the protocols. So we have the famous International Organization for Standardization, which actually is the one that is in charge of the ISO. We also have the International Telecommunication Union, actually that is the ITU-T. This is a body that also governs how communication happens within the network. There are quite a number. We also have American National Standard Institute, Institute of Electrical and Electronics Engineers. Now, when you talk about protocols, these particular bodies are the bodies mandated to provide or author these particular protocols. Like you realize that, for example, when you are communicating via wireless option, such as Wi-Fi, it is the Institute of Electrical and Electronics Engineers that provide protocols of how communication should happen wirelessly. And the rest, of course, we have Electronic Industries Associations. So let's be guided that every standard organization provides some specific protocols. Bottom line, protocols are meant to provide some guidelines of how communication should happen within a particular network. Now, this particular OSI model that we're going to look at is a layered model. When we talk about a layered model, is that it comprises of different layers, and each and every layer has some duties to perform. So in a network model, such as the OSI, you realize that every layer have some kind of tasks, and there are kind of some dependence, right, between one layer and the other. So they need to communicate in tandem, right? We had talked about the peer-to-peer networks. So here, the receiving and sending device needs to communicate seamlessly in what we refer to as peer layer communication, right? And of course, we also need to understand that in each and every device, be it the receiving or the sending device, they need to have both those set of layers. So if a sending device has to send some message, it has to go through the 7 layers. For the receiving device to receive a particular message, also it has to go through the 7 layers. So ideally, we need to look at an example of how we communicate, maybe, or how we pass message in our day-to-day life. Like if you go to, or if you want to maybe send a parcel, for example, right? This is just an analogy of how OSI model represents communication within a network. So if you're a sender, like for example, you can see here, a sender, you have to write a letter, for example, put it in an envelope, drop it in your mailbox. Someone is going to pick this particular mailbox to the post office. right? And then the letter is delivered to the post office via some form of carrier. So that is the sender. On the recipient end, they'll also do the same. So it's going to be picked from the office by a carrier. Then the letter is carried to your post office, from the post office to the mailbox. Then you can always pick that particular letter, right? Read it and so on. Now, this is just an example of how the OSI model is going to work, because the sending device needs to go through the 7 layers. In our case, it's just 3 option, right? And of course, the receiving device also has to go through the 7 layers. And that's what is going to inform the purpose of the OSI model. It was established in 1947, as you can see, and it's based on the ISO organization. So OSI simply means Open Systems Interconnection model, and it actually consists of 7 layers, as we're going to see. So don't confuse the two. The ISO is the body that actually came up with the OSI, right? So someone is going to ask you this just to confuse you, but ideally Open Systems Interconnection is the model and ISO is the organization. Talking about the OSI model, you can see this is a representation of the 7 layers. Now, you are expected to understand these 7 layers. There's no network student who should actually talk about communication in a network if you don't understand the 7 layers. So you have top-down layers. You can start from bottom up, right? So you can always pick a way of understanding these particular layers, because someone can ask you to discuss the 7 layers and tell us what maybe the first layer represent or what physical layer is all about, right? So from the top up, top bottom, maybe you can use some acronyms such as all people seem to need data processing. That could be one option. Top or bottom up, you can use please do not throw sausage peas away. Just some acronyms, something that is going to help you remember, because it's a bit hard for the first timers to understand all these, but just ensure that you have a way of remembering them. So as I'd mentioned, you'll realize that every participating device, that is sending and receiving device, needs to adhere to the 7 layers of the OSI model. So we're going to step by step look at all these particular layers, and we need to understand maybe the devices that are used in a particular layer, the protocols that are used in a particular layer, what communication happens, and so on. Each layer performs a particular specific task, and I've mentioned that they need to communicate. The upper layer and the bottom layer needs to talk to each other, right? So that at least if there is some kind of message to be passed, they know how to convert this particular message. If there's some kind of device that needs to convert the syntax, that needs to be done in a peer-to-peer process. So peer-to-peer process, as I'd mentioned, this is just communication between the two the devices within the OSI model layers. It can be upwards, downwards, right? So each and it could be a sending device. It has its own message that it passes from up, bottom. A receiving device could also be passing this particular message from top up. Now it depends. We have looked at the analogy, how you can send your message from the post office, or rather to the post office, until the recipient gets this particular message. So ideally, the interface that provides this particular communication between the upper and the lower layers are going to be based on some set of protocols, because they have to communicate. So which protocols are within a particular layer? Which protocols are they going to communicate with on the upper layer or the lower layer? Now, in a typical scenario, this is how the layered network model is actually implemented. So you can see the sending device. You can say it is device A, and also we have device B. It doesn't really matter. We don't have any structure As long as we have two participating devices, they can always start from top, bottom, or up, or bottom up, right? So all we need to understand is just what happens in a specific layer. We need to also take note of the bottom layers. As you can see, we have physical, data link, and network layers, right? They are very, very crucial. These ones represent host-to-host communication. So someone can ask you, which are the layers that represent host-to-host communication? Like they kind of have physical, right? You have to connect some kind of equipments or devices. The upper layers, from transport to application, they provide what we refer to as process-to-process communication. That means they are not really concerned of the connection. They're just concerned with specific, it could be application or a process within application, right? That's what the upper layers are concerned with. So ideally, as I'd mentioned, there's some kind of peer-to-peer relationship between these particular layers, right? Because as you're going to see, the physical layer is mandated into transforming data into bits, and that's why you can see ones and zeros, so that it passes through some kind of what? Media. It could be wireless media, it could be wired media, the ones that you had mentioned last time, right? So as you can see here, we have a device, like the first device here on the left shows that it is communicating downwards, the OSI model. Then the recipient is communicating up the OSI model. So all we need to understand is how these particular layers operate or function, right? So let's maybe look at the first layer, and we are going to look at, we are going to start with the physical layer, maybe going up, data link layer, network layer, transport layer, all the way to session layer. So yes, what is a physical layer? First, we need to understand maybe what kind of devices operate here. Of course, these are just cables. If we talk about guided media, and of course, you can also talk about wireless communication. So what you need to understand here is that message is converted into bits, or what we refer to as electrical signals, right? So we can also talk about some kind of topology, how topology are connected. We looked at the various topologies. We also looked at the various modes of data communication. These ones happens. The kind of media that you use will determine whether you're going to use simplex, half duplex, or full duplex. So ideally, point to take home here is that the physical layer is responsible for actually converting messages into bits and transmitting them from one node to the other. Mainly in a network scenario, we talk about one hop to the next hop. Hop simply represent a device or a node, right? So physical layer, as the name suggests, things are done physically, right? So these are cables that are connected via some kind of, that passes some kind of message in forms of bits. From the physical layer, we move to the second layer of the OSI model, which is the data link layer. Now, underline the word link. So also, it offers some kind of connection, right? So here, devices, or the devices that are used in the data link layer, enables movement of data, or what we refer to as frames, from one computer to the other. Remember, within the physical layer, we mentioned that the data is converted to bits. In the data link layer, data is represented as frames. Now, frames are just some kind of chunks of data, right? So you have the bits, then you can represent them in terms of bytes, kilobytes, and so on. All right. Now, these ones, when you represent them in the data link layer, we refer to them as frames. What are the protocols that are used here? We always represent the frames, or rather the communication happens within the data link layer based on the physical addresses. Now, these physical addresses, some will refer to them as the MAC addresses that are found within the computer, right? I'll share some write-ups so that at least you understand what these MAC addresses are. In a data link layer, it offers some flow control. What is flow control? Flow control is how a particular sending device pushes data to the end device by ensuring that the end device receives the intended data, right? So it passes the, we refer to this as windowing. End device can only just cope or just receive some chunk of data. So it's the responsibility of the data link layer to ensure that it understands how much a particular receiving device can be able to accommodate. Error control, we also have what we refer to as checksum. Checksum sequence happens within the data link layer. If you send, let's say you have sent, let's say a device has sent a frame that has 7 parts, right? It is the responsibility of the end device to count if those particular frames are 7. That is what we refer to as error control. And of course, access control, which particular device is intended to receive this particular message. So bottom line here is that data link layer is responsible for converting the message into frames and then passing them to the next device. What are the devices that are used here mainly? We have the switch, right? We talked about the switch. Switch is also referred to as layer 2 switch. Also, a bridge can be used within the data link layer, right? So you can see here how this particular data link layer is implemented. You can see there are quite a number of links, right? So the communicating devices are actually linked using the MAC addresses. MAC addresses are some kind of characters or alphanumeric characters that uniquely identify a particular device within the local area network, right? So I know this diagram is a bit hard to understand, but what we need to know right now is that if it is a switch, you can see those devices, there's some kind of icons with an X, right? I don't know if the color is pink or what. Now those devices represent the switch. So switch has the mandate of determining where a particular message is to be sent to. Is it maybe a computer F or computer D, right? Using the physical addresses. So as you can see here, the frame is actually appended with the source and the source address and the destination address, so that it determines where this particular device has come from, or where this message has come from, and where is it intended to go to. So this is just a typical frame. You can see it as a trailer that consists of extra information, right, like the headers and so on. From the second layer, we move to the third layer, which is the network layer. Network layer, the devices that are used here normally are the routers, and that's where the term routing comes from. Routers has the capability of providing some logical addressing. We looked at the various types of network devices, and we talked in depth about what a router does, so I won't really repeat that. What do we need to understand with a network layer? Here the message is converted into packets, right? So when you hear that, maybe someone tells you that routers are actually mandated to pass a message from one network to the other, they actually pass what we refer to as a packet. The famous protocol that is normally used here is the IP, the Internet Protocol. So when you configure a particular device, you normally give it some unique address, and that is the IP address. So you can see the upper layer, which is the transport layer, needs to communicate with the network layer, and of course the network layer also needs to communicate with the second layer, which is the data link layer. What is transmitted within the network layer are the packets. Which device is used to communicate within the network layer? Mostly it is the network, the router, and so on. So here, the X's represent the router. Router doesn't extend a network, but it creates a new network. So any port that links to a network, to a router port, or rather any connection that links to a router port, that one creates a new network, right? So we need to understand the difference between a network layer and a data link layer. When we talk about packets, they also contain, I don't know whether this is captured here, but packets also contain additional information such as source address, destination address, and other additional information such as the checksum sequence and so on, right? So as you can see from this diagram, the source to destination delivery, the bottom layers are used to achieve what we refer to as host to host communication. That is the physical data link and network, right? So what I've just been explaining here is how communication actually happens, right? So the router is mandated to use an IP address, normally referred to as a universal address, to pass or rather send the various packets across the network, right? So ideally, after network layer, we have the transport layer. This is the fourth layer of the OSI model. Transport, as the name suggests, it carries, it transports the message from one device to the other through some given process. Now, the two protocols that are normally used here are the TCP and UDP protocols. TCP, these are the transmission control protocol, and UDP, we have user datagram protocol. Now, one protocol, which is the TCP, provides what we refer to as connection-oriented communication. What do you mean by connection-oriented communication? It simply means that when the communicating devices use TCP protocol, there's some kind of acknowledgement that what was submitted or sent was received or not, right? So that's the TCP. Connectionless is the UDP, user datagram protocol. This one doesn't care whether the end device received that particular message or not. That's why we talk about the connection control as either being connection oriented or connectionless. Now, here we don't really have a device because it's a protocol, a process to process communication. So normally there's just kind of administering some flow control, right? So that whatever is being passed or how the processes communicate, we can always manage this particular communication. Now, here requires an additional understanding of what we refer to as inter-process communication in different devices, which is actually beyond the scope of understanding. So anyway, it is mandated to deliver a message from one process to the other. That is the transport layer. So as you can see, here the message is crafted into what we refer to as segments, right? So transport layer, because it transports data, it has to now break them into what we refer to as segments. Now take an example of a lorry that wants to transport some items. Maybe the size of the lorry cannot handle the items that is to be transported. So what does the lorry, what does it do? So you have to transport some, you have to break those or group those particular items in a way that you can be able to transport them. So the first batch is transported, and then the second batch, and up to maybe the 10th batch, right? Now, the receiving device needs to check those batches and ensure that all those particular segments have been received. So once those segments have been received, it offers or issues what we refer to as acknowledgement that everything has been received. That's why we normally talk about delivery, yes, using TCP protocol. So if the segment has issues, you'll get the notification such as message not delivered and so on. So points to take home here is that transport layer offers some kind of delivery. This delivery can be through connection-oriented mechanism or connectionless. In a transport layer, we offer communication through process to process, right? We don't have host to host. Like in a network, you can see network layer offers host to host. In fact, even a data link also offers host to host. But in a transport layer, we have process to process delivery. So here is how this particular transport layer functions. I know they are kind of, so these are different segments, data that have been separated, right? So the sending device needs to ensure that all the data has been sent. The receiving device needs to counter check that whatever was sent is actually the right thing by looking at all the segments, right? Then we have the session layer. I believe this is now the 6th layer of the OSI model, right? Now, what is a session? Let's say you want to talk with someone. You normally establish a session, right? Now, we have three categories of session. First of all, you establish a session. Now, when the communicating device and when the two communicating devices want to talk to each other, they establish a session, right? Then, after establishing the session, they pass the message. After the message has been passed, they terminate the session. So those are 3 steps that happens within a session layer, right? So it establishes, maintains, and ensures that whatever is passed is done within some timing. That is synchronize the interaction between this particular system. So all this offers dialogue control. So they establish the session, right? So yes, are you ready to send? Yes. Then after that has been sent. Now, synchronization happens in real time. We have asynchronous and synchronous communication. So in a session layer, normally, mostly synchronization happens, right? So that it determines that the communication flows seamlessly in real time. Now, ideally in a session layer, also we offer what we refer to as process to process interaction, right? The upper layers actually doesn't engage physically with the devices, as you have seen the way the first, second, and the third layer engages, right? If the session is not terminated, chances are there could be some overflow, right? Overflow, or rather someone can be able to tap into that particular session, right? And hack into the conversation that is happening. So it's very, very important that when the two session or the two communicating devices are in session, the session needs to be terminated, right? So ideally, at the top layer is the presentation layer, then we have session layer, and then we have transport layer. So here, communication, or rather message, it gives the window where the message is passed through sessions. Physical layer, bits. Data link, frames. A network, packets. Transport, segments. A session, we are talking about sessions. Then we have presentation layer. Now, presentation layer, as the name suggests, this is now where the syntax comes in, right? Ensuring that the message that is passed conforms to a specific syntax. So it has some mechanism of how to do or perform some translation. Let's say if the context of the message needs to be translated, it does that. Encryption normally happens within this particular layer. And of course, if you want to compress a particular message, it happens through. Ideally, presentation is just how to package, how we package, or the communicating devices packages a particular message before it transmits this particular message, right? So as you can see, we have the topmost layer, which is application layer, communicating with the presentation layer, and then presentation layer communicates with the session layer. So within the presentation, we talk about compression, conversion, translation. I'm just trying to look at an example. A typical example is ideally when you want to maybe send an audio file, right? And you want to determine maybe how it can be converted, and maybe you have also so audio files are normally, how do you establish an audio file? You need to have the right maybe softwares to open this particular audio file, right? And of course, you can also have text, you can also have video files. So how you open these files and maybe look at what is inside and everything. I hope you get that, right? So it allows you to understand, it allows you to understand encryption and decryption, to understand the content of the message, and so on. Lastly, we have the application layer. That is the top most layer of the OSI model, right? Application is application. You need to have some applications to be able to maybe read some content or send some email, for example, right? So in an application layer, you bring on board different applications, such as we can talk about even the browsers that allows you. You see, browsers perform a lot of tasks behind the scene, right? It enables us to read the websites or the web pages, right? You want to download a file, for example, you need to use the file transfer protocols. You want to pass some emails, you need to use the simple mail transfer protocols, right? You need to log into a remote machine, you use some kind of virtual terminals that you have. So ideally, just like the normal applications that allows a user to perform some specific tasks, the application layer offers services to the user. So without application layer, the user cannot really interact with the network, in simple terms, right? So at the point where you want to consume, or rather see what is being communicated within a network, then you use the application layer. So as you can see, there's X500. These are just some examples of protocols. Like this one, X400 is for sending emails, right? So you need to, within application layer, you need to have some application that enables you understand what is being passed. So in summary, we talked about the 7 layers, as you can see them, from bottom up and top up, top bottom. So you can see a physical layer there, message is being transmitted via bits over some medium. We also have talked about data link, where bits are actually transformed into frames. We also have packets being sent within a network layer. And of course, you have transport that offers process-to-process delivery. We have seen how to establish manage sessions, and of course, how to encrypt, decrypt within the presentation. And of course, the application layer that allows us to access various network resources, right? So should someone ask you to explain one of the reference models, which happens to be the OSI, you should be in a position to. So you need to understand in details. First, what are the protocols? I've so far mentioned 1 or 2, 3 protocols that you can find within this particular layers. Also need to understand the functions, right? The typical functions, the general functions of these particular layers. And most importantly, if you can identify, for example, within the lower layers, the devices that are used to pass or to communicate within a given network. So that is actually how the OSI works, and basically those are the 7 layers of the OSI model.